See how to find arithmetic mean of n real numbers. Okay, we have already discussed for 2 real numbers, so let us discuss for n real numbers. So for a1, a2 and so on n, suppose these are real numbers, then arithmetic mean is simply average of all these numbers. So that means a1 plus a2 plus and so on n divided by n. Okay, so that means simply we take an average and we get a arithmetic mean. So let us see how to find geometric mean. For geometric mean, we need to have positive real numbers only. Okay, so therefore I will write for a1, a2 and so on n. If these are positive real numbers, then geometric mean is nothing but nth root of product of all these real numbers. So a1 into multiplication n2 and so on n. See, we take a nth root of their product, so we get a geometric mean. Is it clear to you? So in last lecture or in last video, we have seen arithmetic and geometric mean of 2 real numbers only. So that's why we had taken 2 there, but here we are talking about n real numbers. So that's why I'm taking nth and I'm taking here nth root. Okay, make a screenshot of it. After that we will discuss one theorem here. Let us discuss proof of this theorem. So in this theorem, we have to prove arithmetic mean is always greater than or equal to geometric mean. Okay, so already we have proved this theorem, but only for 2 real numbers. So now we are going to discuss it for n positive real numbers. So to prove this theorem, we are going to follow principle of finite induction. Okay, so which involves 3 steps. I think already I have told you about this. First, we prove the result is true for n is equal to 1. Okay, we prove it. Second step is quite easy. In this case, we assume result is true for n is equal to m. It is very easy. Simply we have to assume and we have to go further. And in last step, we again prove result is true for n is equal to m plus 1. So simply we have to follow these 3 steps. Okay, after completing it, we can declare by the principle of finite induction result is true for all n. So let us do that. I will mention, we will prove this result prove this theorem using principle of finite induction on n. Okay, on n. So see, what is our first step? N is equal to 1. We have to prove result is true for n is equal to 1. But instead of n is equal to 1, we will start with n is equal to 2. N is equal to 1 means only one real number, and we cannot find arithmetic mean and geometric mean for one real number. So we'll start with n is equal to 2. So for n is equal to 2. Okay, so here our first step is n is equal to 2. So we will have 2 real numbers, positive real numbers. For a1, a2 belongs to r plus, positive real numbers. Okay, we know that clearly. I will mention clearly. If you take square of any real number is always greater than or equal to 0. If you take square, definitely it is greater than or equal to 0. So you know the bracket square formula, a minus b bracket square, a square minus 2ab plus b square. Let us follow this formula here. So root a1 square minus 2 root a1 root a2 plus root a2 square greater than or equal to 0. Right? So square and square root will get cancelled. So a1 minus 2, this is root a1 a2 plus square root cancel, a2 greater than or equal to 0. After that, what will I do? The middle term I am going to shift on that side. Let me remove this part. It's not required now. Okay. So I will write the remaining part here. So therefore, a1 plus a2 greater than or equal to 2 root a1 a2. After that, I am going to shift this 2 on this side. So therefore, a1 plus a2 divided by 2 greater than or equal to root a1 a2. Okay, this is nothing but arithmetic mean of two real numbers, and this is nothing but geometric mean of two real numbers. Okay, so in this way we proved result is true for, yeah, we proved no arithmetic mean is greater than or equal to geometric mean, but for two real numbers. So therefore I will declare, therefore result is true for n is equal to 2. Okay, so the first step we have completed here. So our second task is to assume, yeah, it's very easy, assume result is true for n is equal to m. You can make a screenshot of it, then we will go further. So now we have to prove the result is true for n is equal, assume n is equal to m. Okay, see, assume that result is true for n is equal to m. That is, so result is true for n is equal to m. That means if you have m real positive real numbers, then arithmetic mean is greater than or equal to geometric mean. That is, for a1, a2 and so on, m belongs to R plus, then arithmetic mean is greater than or equal to geometric mean. That is, a1 plus a2 plus and so on am divided by m greater than or equal to mth root of a1, a2 and so on m. Okay, this thing we have assumed, getting? So yeah, the second step is also completed. It was quite simple. What is the third step? In third step, we have to prove again the result is true for n is equal to m plus 1. Let us do that. For n is equal to m plus 1. To prove that result is true for n is equal to m plus 1. That means in this case, we have m plus 1 positive real numbers. For a1, a2 and so on, am plus 1 be positive real numbers. Okay, so obviously they will have arithmetic mean and geometric mean also. We will call arithmetic mean by am plus 1. Okay, so let am plus 1, that means arithmetic mean, okay, of all this. How to find arithmetic mean? You know that a1, a2 and so on, am plus 1 divided by m plus 1. I'm dividing by m plus 1 because there are m plus 1 real numbers. Okay, so this is am plus 1. So there is no more space to write. You can make a screenshot of it, then we will go further. See, now we assume that all these numbers are arranged such that a1 is the smallest and am plus 1 is a largest number. Getting? So that means we are simply we can say we have arranged all these numbers in ascending order. a1 has the smallest value and the last number am plus 1 has a maximum value. Okay, so in that case I can write, so therefore see, what can I write? a1 plus and so on a1 m plus 1 number of times. This is less than or equal to a1 plus a2 plus and so on am plus 1. Here getting, so I could write it by assuming, see, first one a1 is equal to a1, no doubt. Second number a1 is less than or equal to a2. Okay, if you compare all these numbers sequence wise, the a1 is less than or equal to am plus 1. Since a1 has the smallest value, okay, so that's why if you add in this way, we will have this inequality. We are adding a1 m plus 1 number of times, so therefore m plus 1 into a1, see this part is same, a1 plus a2 plus and so on am plus 1. Okay, same going to shift this m plus 1 on that side. So therefore a1 less than or equal to a1 plus and so on am plus 1 divided by m plus 1. So therefore, a1 less than or equal to a m plus 1. This is nothing but arithmetic mean of those m plus 1 real numbers getting, and we have already denoted it by capital A m plus 1. So we got a1 less than or equal to a m plus 1. So I will call it as star. Similarly, what can we write? Similarly, see, a1 has a smallest value, okay, so which is the smallest number, and am plus 1 is the largest number. So for am plus 1, what can I write? I can write in this way: a1 plus a2 plus and so on, am plus 1 less than or equal to am plus 1 plus am plus 1 plus and so on, am plus 1. How many number of times? M plus 1 number of times. Getting? Since m plus 1 is greater than or equal to a1, m plus 1 is greater than or equal to a2, since it is a largest number, no? So that's why we could write in this way. So therefore, we have a space here, we will use it. So therefore, a1 plus and so on, am plus 1 less than or equal to. See, we have added am plus 1 how many number of times? M plus 1 number of times. So therefore, m plus 1 am plus 1. Can you guess our next step? That m plus 1 I am going to shift to the denominator of left hand side. So therefore, a1 plus and so on am plus 1 divided by m plus 1 less than or equal to am plus 1. Do you know this is what? This is arithmetic mean of m plus 1 real numbers getting, which is nothing but am plus 1. Same thing we have got here. So therefore, am plus 1 less than or equal to am plus 1. This is double star. See, if I combine star and double star, so I will mention here from star and double star. See, what will you get? 0 less than or equal to, see, I will shift a1 on that side, am plus 1 minus a1, okay. You are getting my point. From star, what can I write? By shifting a1 on that side, 0 less than or equal to am plus 1 minus a1. And what can I write here? 0 less than or equal to, I am shifting am plus 1 on that side, so am plus 1 minus capital A m plus 1. See, this is positive, that means non-negative. This is also non-negative. So if you take their product, then also it is non-negative. So therefore, 0 less than or equal to am plus 1 minus a1 into am plus 1 minus am plus 1. Okay, so there is no more space to write. You can make a screenshot of it, then we will go further. Hello, okay. So see, let us simplify it. So therefore, 0 less than or equal to, we will solve these two brackets, okay. So am plus 1, okay. So minus a1 am plus 1. Next, this one into that one, minus am plus 1 square we will have, and minus minus plus a1 am plus 1. See, only this term I am going to shift on this side. So therefore, a1 am plus 1 less than or equal to. See, from remaining terms, I am going to take am plus 1 common. So therefore, am plus 1 in bracket am plus 1 plus a1 minus am plus 1. Okay, that capital am plus 1 I have taken common, so there were two terms. So that's why if you take one, take common, we will have simply am plus 1. So there is multiplication. If you shift it here, there will be division. So therefore, a1 am plus 1 divided by am plus 1 less than or equal to am plus 1 plus a1 minus am plus 1. Equation triple star. A very important thing we have got here. Okay, let me remove this part, it is not required. See, we have already assumed result is true for n is equal to m. We have assumed that thing, okay. So let us take some m positive real numbers. Consider m positive real numbers as, see which positive real numbers we are considering, a2, a3 and so on m. How many real numbers are there? A2, A3, M. So there are total m minus 1 real numbers. Since A1 I have not considered there. Okay. So one more number is required for having m positive real numbers. So that real number I am going to take A m plus 1 plus A1 minus A m plus 1. See this positive, this is a complete last positive real number I am going to take. So how many real numbers we have? These m minus 1 real numbers plus this one real number, that means total m real numbers. So we know that result is true for n is equal to m. I will mention we have result is true for n is equal to m. So therefore arithmetic mean is greater than or equal to geometric mean. So let us find their arithmetic mean. Arithmetic mean will be a2 plus a3 plus and so on am plus this last real number am plus 1 plus a1 minus capital am plus 1 divided by m, since there are total m real numbers, which is greater than or equal to geometric mean. So mth root of their product. So a2, a3 and so on am, and this last real number am plus 1 plus a1 minus am plus 1. So this is the last real number. Get it? So if you add, I'm going to write properly. So therefore there is a1 plus a2 plus and so on am plus 1 we have, getting na, minus am plus 1 divided by m greater than or equal to mth root of a2, a3 and so on n. See, but already we have proved here in equation triple star, this bracket is greater than or equal to this one, getting? So therefore this is greater than or equal to, I can write a1 into am plus 1 divided by am plus 1 from triple star. From we get this inequality. Okay, so no more space to write, make a screenshot of it, then we will go further. See, but you remember the formula of m plus 1, but am plus 1, that means arithmetic mean of first those m plus 1 real numbers, okay, divided by m plus 1. So therefore if I shift m plus 1 on this side, so therefore m plus 1, okay, am plus 1 is equal to a1 plus and so on am plus 1. See, same thing we have got here, na? a1, a2 plus and so on am plus 1. Which value is this value? I am going to put it here. So therefore, see, therefore what can I write here? M plus 1 am plus 1 minus this am plus 1 divided by m, and which is greater than or equal to mth root of see, product of this. See, in all numbers we have a1, a2, a3. I will write in a proper sequence a1, a2 and so on am plus 1 also we have, and in denominator we have capital am plus 1. Let me remove this part. We have used this equation inequality. Okay, see, we can take am plus 1 common. So therefore m plus 1 and this minus 1 am plus 1 divided by m. So to remove that mth root, I am going to take mth power of both sides. Okay, raised to m and greater than or equal to a1, a2 and so on am plus 1 divided by m plus 1. Okay, so what will happen? 1 and minus 1 will get cancelled to each other, right? So therefore we will have m plus 1 divided by m raised to m greater than or equal to a1, a2 and so on am plus 1 divided by m plus 1. Okay. See, will get cancelled. That means simply what will you have? Therefore, a m plus 1 raised to m. I'm shifting this m plus on this side. So, a m plus 1 greater than or equal to a1, a2 and so on, a m plus 1. So, you can make a screenshot of it, then we will go further. See, both of them have a same base, so we can add power. So, therefore, a m plus 1 raised to m plus 1 greater than or equal to a1, a2 and so on, m plus 1. After that, I am going to take m plus 1th root of both sides. So, therefore, a m plus 1 greater than or equal to m plus 1th root of a1, a2 and so on, m plus 1. This is nothing but geometric mean, right? So, therefore, a m plus 1 greater than or equal to gm plus 1, geometric mean. So, that is arithmetic mean is greater than or equal to geometric mean. Okay, so let me remove this part. So, therefore, we proved for m plus 1 real numbers also we get the same inequality. So, I will mention therefore result is true for n is equal to m plus 1. So, in this way we done all these three steps. First we proved result is true for n is equal to 2. After that we assume result is true for n is equal to m. And again we proved result is true for n is equal to m plus 1. Therefore, by principle of finite induction, therefore, by principle of finite induction, result is true for all n. Result is true for all n belongs to set of natural numbers. Okay. So this proof is over. You can make a screenshot of it. After that, we'll stop. Thank you. Bye bye.